Okay, dear friends, today we are going to prove a very beautiful fact in the second episode of Creative Physics Questions Problems. And these problems include the conservation of energy and a very beautiful geometric fact about uh, slopy planes. So let us start with giving some information. Let's say we have a arc over here, which doesn't necessarily have to be a semicircle, but we have 3 points A, B and C over here. C is lower than both A and B is lower than A. So the problem claims that when we let an object with a constant mass over here slide over this slope, the slope between A and B, it will take TAB times. And then we have machinery in point C, which just changed the direction of velocity of a common object from here to here. So it means if we let an object slide from here, it will come to point C and it will unnecessarily changing the velocity to go B. Okay, and the duration of time will be given by TAC plus TCB regarding the points. And the claim of the problem says TAC and TCB combined will be smaller than TAB, which is very unintuitive, but we will try to prove it today. So let's see how we can prove it. We just have to know another very beautiful fact about geometrical structures. Let us say we have a semicircle like this. It is not a very beautiful semicircle, and this is the top point. Let us call this point K. And let's say this is the diameter of our circle and its radius is R. And another assumption, let us say whenever we let an object slide over any slope, making an angle of alpha over here, it will reach to this point regardless wherever the point is. Let us say the point X. Wherever the point X, it will reach to that point on this circle in the same time. Let us call that time t. So we have to prove this first, then we will go back to our problem and try to prove that one. So let us see. Let's say this part of line has a length of L, and we will see how many seconds do we need to cover this L with a constant acceleration movement. So first we will have to see our acceleration, which is A equals g times sin alpha, which is obvious from our very basic mechanical knowledge. So then we will have to see that as the first velocity is 0 over here, the time will be given by t equals, of course, from where, let me show you that one. The L will be equal to 1 over 2 g times sin alpha times t squared. So it will look like this, 2L over g sin alpha, right? So this is going to be our time, which will give us t. As you see in this equation, t is dependent to alpha. Well, not really. When we look at the geometrical properties of this object over here, the circle, we can see that when we divide it from here, we have alpha over here, but as this right triangle sees the diameter, we will have another alpha over here. So the L will become what? L will become 2r times sin alpha, right? So when we write it inside this equation, it will become like this, 2 times 2r sin alpha over g times sin alpha. As you see, sin alphas cancel each other, and we just get a very beautiful equation, 2 times square root of r over g, which is the same as our time. So as you see, our time only depends on the radius of the circle and the constant acceleration of gravitation. So whenever I put that point x anywhere on the circle, it will reach to that point at the same time, whatever happens. So we will use this fact solving our problem. So let us go back to our problem and see that when we draw another circle, let us draw that in which purple. Let us draw that over here. So that circle will look like this. Just another circle. It is have to be a semicircle. It starts from A slope goes here, and another slope goes here. So in this part of the question, we see that these two sections, this is 1 and this is 2, actually will cover the same time. Why? Because we saw that whenever we put an x point on a semicircle, our object will travel to that point in the same interval, wherever we choose. So in the problem setting, we put 2 points. Let us call this point K, and we have C. So this interval and this interval will be the same. So whatever happens, we will see that this interval will look like TAB minus TAK. So that is our interval for this point between K and B, right? Let us say TK and B. On the other hand, this interval will stay the same because we just destroyed TAC, and TAC is the same as TAK. So we have TCB only. So to prove this part, we will have to change that a little bit. How? Let us go down and we will see. Let me change the color of my pen. So we said TAC plus TCB is smaller than TAB. And we also said that TAK is equal to TAC. Sorry. TAC. So when we subtract TAC from both sides, we will get TCB is smaller than TAB minus TAK, which is TKB, right? Over here, let me show you. So we subtracted TAC from TAB, which is TAB minus TAK. So our answer becomes, if TCB is smaller than TKB, then our question, our claim over here is correct. So let us see if it's correct or not. Now we have to prove this fact, okay? This claim, rather. So how can we prove it? Let me make my pen black again. So it looks like this, right? We have 3 points right now, which is K, B, and C. And let's say I have another circle taking these points inside. Let us call the center of the circle O over here. And we have these slopes. We do not use this part, but we will see something else. This angle sees K and B, and it shows us a bigger arc. But on the other hand, this angle, this smaller angle, let me write it in another pencil, another color, it shows this side. So which is basically apparently smaller than KB. So we can say the length of CB is smaller than KB. But is it enough for us to prove that TCB is smaller than TKB? No. We just have to know, or at least predict, the velocities. So let us predict velocities. Let's say we have the object over here moving with a velocity of v1, and that v1 will increase because it makes a motion with constant acceleration, increasing speed. On the other hand, we have another situation over here. Our object moves with v2, and that v2 will always decrease because its kinetic energy turns into potential energy when it goes from C to B. That's why we said C was a lower point than B. So the graph will look like this for both velocities. Let us say this is v1 and this is v2. And let's say for both objects the velocity will be v3. That is actually the conservation of energy, because wherever we started from the point A, which is basically an outlier in this geometrical shape. The final velocity will have to be the same because the energy is conserved. There is no friction in this question. So let us draw this velocity and time graph. So v2 will always decrease because v2 is going upwards. Second object, let us call this point v3. It will decrease to v3. But v1 will always have to increase because it has a slope and it has constant acceleration. So in this interval of time, it doesn't have to be at the same time. It may take more time for v1 or it may take more time for v2. But we will know that at reaching to this point, v2 has always bigger velocity than v1. So an object moving on this side will always have slower or lower velocity than the object moving on this side. And we also know that TCB is smaller than, the length of CB is smaller than KB. So we will have to show this. We know that, let us call the average velocity on this side V2 average. And let us call the average velocity on this side v1 average, because it's only convenient as we use it. And we know that v2 average is always greater than v1 average from the graph, because v2 is just slowing down to go v3, although v1 is just increasing its velocity to v3. So v2 average is always smaller than v1 average. So move on from this point. So for time, for TCB, we can calculate TCB over here. TCB will become CB over V2 average. Also, let me change the color of my pen. TKB will become KB over V1 average. So let us just compare these two values. We have on one side CB over, let me change the color. CB over V2 average and KB over V1 average. We already know that V2 average is bigger, so it makes this ratio is even smaller. As CB is smaller than KB, this is very, very small than KB over V1 average. So we actually proved it. TCB is smaller than TKB, and in turn TAC plus TCB is smaller than TAB. We made a very beautiful proof for a very beautiful fact over here. I hope you enjoyed the question. It's very unintuitive, but once you learn it, you just enjoy it. So see you in the next video.